Mail time. Videos have slowed a little bit, admittedly. I took about a month off making really any content. I was busy with other things. Here's the only package that has come in that time, at least concerning the channel. And, yes, this is exactly what I thought it was. It's this little box here. Now, what is this little box here? This is a grid tie micro inverter. So you see houses and they've got a whole roof completely covered in solar panels. I can't afford that many solar panels. So I got a $100 inverter and I've got one big solar panel. Admittedly, I've got no idea how much power this is actually outputting. I didn't realize it until after I had purchased it. But there we go. Here's a panel that is cracked, and there's another that is cracked. So there is the potential that I have lost these two rows here entirely. So the power generated by this is probably going to be a bit less than its maximum output power of 140 watts. And the little inverter can handle an input power of 350 watts from the solar panels. So that's 350 watts going in, but its max output power is only 320 watts. So it's not a perfect in and out. So without a proper way of testing this, let's get it hooked up and see what happens first. Because this is just a test, I am going to use temporary connections to make these connections. I know the solar panel works at least a little bit because it's able to power this little solar controller. This solar controller, though, is pretty useless and is made specifically for connecting to batteries, which isn't super useful if you don't have the system that will also turn it into useful power for you to use in the house. Where this little inverter box is able to do that in real time and allow you to use that power straight away, as well as making sure that it doesn't island you and your home. Now that means if there is a power cut, it will stop putting power into your home power network. Because if you keep putting power into it, your home is still connected to the wider grid, which will then feed other houses if you're producing enough power, which is very dangerous for the linesman that is trying to fix whatever caused the power outage in the first place. And it would also put probably some unnecessary strain on your part of the power network. So it's got sensors in there to make sure that that does not happen. Because I don't have any proper testing method as of yet, I do have this circuit here. Now, if I plug a fan into it, we can see that this fan is drawing 35 watts of power. So, what's going to happen when I plug this in? Is it going to go into the negatives, saying that this is producing power into the network? Or is it just going to give me a positive reading, even though the flow of power is in the opposite direction? I have no idea. But what I am going to do first is I'm going to plug this into the power grid first and then plug it into the solar panel just to see if this is going to draw any power. It's all wired up correctly, and then I'll plug it in with my phone sitting on top of it for some strange reason. Oh, B. And let's see if it has any power draw or any lights. No lights are on. In any case, it looks like it is not drawing any power right now. So I have disabled it, so it's basically unplugged. And now I will connect the solar panel to this device. Here we go. The status light has gone red. which is indicating that there is low or no AC voltage, so it's gone into protection mode. In other words, it's gone into the anti-island protection mode, making sure that this isn't outputting power to a dead circuit. Because if you think about it, imagine it's not plugged in yet and it starts outputting power. That would make these prongs here live, so anyone that accidentally touches it is going to get a shock. Now for the exciting part, I turn the circuit back on. The light on it went green. Ooh, I can hear an uncomfortable noise coming from it. Yeah, I'll put the mic on it. Can you hear that? Honestly, that is a little bit of an unnerving, uncomfortable sound that it is making. But I would assume that if the solar panel was actually outputting the full rated power of this, that it would probably not make that noise, or at least not that noise exactly. Now the downside is that this monitoring circuit that it's plugged into isn't telling me if it is putting the power back into my home power grid, or if it is drawing power and outputting sunlight at a magnificent rate. That's not how solar panels work. But the thing is there's nothing here to specifically say that it is supplying the power network here at my house, but it does say that it is at 76 watts. So I'm going to give it the benefit of the doubt and assume that this solar panel is now supplying the house with 76 watts of power. This really is an optimal day to test this. You see, we've got no clouds in the sky, so I should be getting the maximum result from it. Without getting too mathy, I have found that this is going to be saving me a whopping $5 every single month, which isn't a lot. So assuming we have a perfectly clear blue sky day like we have today, every single day for an entire year, I will finally be at a net zero in terms of how much I've spent on this and the inverter. So it's not really worth it. Which is probably why most houses that have solar panels have a lot of them on the roof. Though unfortunately I'm not able to find any working examples in my neighborhood. I would have to travel to the rich side of town to show that off. Now this is a reasonably set and forget system. Stick the panel on the roof, get this funky sounding buzzy box and put that somewhere, hopefully out of direct sunlight, because it does get quite warm, which might be down to its low efficiency rating. It's only in the high 80s, which, given it's coming from solar, that's not very good, considering how inefficient solar panels still are with today's technology, especially one with a couple broken bits. Now it's the end of the day and the sun is on so much of an angle here that it's producing nothing. In fact, from about lunchtime is when it started to drop off. 7 minutes past lunch, it was at 78 watts. Then at 2:18 it was at 40 watts, and now it is 3 o'clock and it is at 0 watts. It's probably because of the angle. I would say if I did move this just enough for it to catch the sun again, that it's probably going to start pulling some power now. But that would be pretty annoying to have to adjust that all the time. Because it is only producing such a small amount of power, I'm not going to take the time that it would take to mount that on the roof or somewhere more appropriate. Another reason why I'm not particularly in a hurry to put it on the roof is the garage roof quite quickly loses sunlight. So it might be viable if I put it right at the front over there, because the sun arcs over there. But this house that I just so happen to be living in is kind of in the way to do something like that. And of course the other end of the garage gets blocked by that satellite that doesn't get used. Now, for health and safety reasons, I'm not going to show how I got this solar panel up here. It didn't take me very long to do so though. The installation of this panel was not very difficult. I sat it in its place and drilled a couple holes, put some rivets in, and then I was able to run my makeshift cable through and into the garage. Running the cable through the rafters and then down over by a plug where I'm able to plug the conversion inverter unit in, I was able to find a reasonably good and comfortable space for this equipment to live. Even though it's not going to be producing a lot of power, every little bit counts, and I'm sure it's worth it in the end. The benefit of this is that it is a set and forget system. I don't think about it at all anymore. With all that solar nonsense out of the way, it's time to get back to working on the go-kart. In the previous video, it was revealed that we had some major structural integrity issues. So we spent the majority of the time welding, grinding, and fixing that. With that mess dealt with, I'm now able to reinstall the battery holders so that we can finally lower this cart back down to rest on its own 4 wheels. Yeah, look at that! And for the first time in what feels like forever, the cart is on its own 4 wheels on the ground and the frame is not snapping in half. It was quite the snap that happened. I was riding along at full speed, of course, and then I turned one way and the front wheel snapped off and I just hit a curb pretty well head on, which surprisingly actually broke this front battery mount. It hit it so hard it broke the rivets out, but it didn't damage the battery. As far as I can tell, the battery is still operating normally. But I believe that is when the bit of the frame broke. I didn't know it at the time, so I fixed the front wheel and I kept riding around, and then I realized that the battery bank was dragging on the ground every now and then, indicating that something needed to happen. With that little bit of exposition out of the way, we can begin improving upon the build. First, I'll be finding some materials to use, namely what's left of the microwave casing we pulled off in a previous video. With this piece of metal, I'm hoping I can build a bit of a frame to hold and secure both the motor controller and the battery that lives in this back section here. So like this front section, I want it to have a front and a back as well as both sides covering it so the battery is less likely to get damaged. Though ironically, the very front battery holding area has no such protection. The good thing is I've basically done it before with the previous version. It just held differently because the motor controller was entirely different. The tricky part about this motor controller is rather than having all the cables coming out and been able to feed them places, I've actually just got connections in here where everything has to run to. That said, I do have a loom that comes with this controller for all of the low voltage database things that don't require high power, thick cables. One interesting thing to note from this new controller's loom is the hall sensor cable on it is made for a more waterproof environment, so I'm going to need a donor connector. Maybe the broken motor controller on Go-Kart number 2 will be the perfect donor. This is the one we're looking for. But cutting off this little connector was a little premature. I still need to build the motor controller holder that will hold the motor controller as well as a battery, the 6th battery of the battery bank. Now, the tricky part about the motor controller housing that I need to build, the cooling fins for this are on the bottom, so it needs to mount like that, where it's got these 4 holes in each edge appropriately. But it means that I'm going to have to cut a hole out of this for this to slot into and mount into place, hopefully securely so it doesn't just fall out the bottom. It needs adequate airflow because knowing the way I drive, this is going to be working hard. So I get to work. Unlike most projects, for this one I'm actually going to take some measurements and have some sort of plan before I actually kick into making things. Being careful and making sure that I'm taking measurements where needed and making a proper plan that has enough detail in it that I still have room to move, both for mistakes and for creative changes I come up with along the way. Plans made, it's time to transfer that information onto the piece of metal that I'll be working with. Though it is pulled off of a microwave, so there is a little more prep work I need to undergo in order to be properly prepared. With all the measurements transferred to the piece of metal, we can now go out back and prepare to cut it as necessary, in the safest way possible. With the cutting done, I can tidy up the edges a bit, spending some time in the sun, then it's ready for marking and bending. With the metal cut and folded, it's time to figure out the placement of the motor controller itself, measuring and marking so I can cut out a hole for it and ensure that it gets adequate cooling. With the controller in place, I can drill some holes to properly secure it to this piece of metal. Upon another test fit, I find that I don't quite have enough of a tab to properly mount this piece of metal in place. My solution for that is to simply get a washer and weld it into place, allowing me to securely mount this. Yeah, I know it's a cutting disc, not a grinding disc. With that established, let's go to Hammer Barn to purchase a bunch of things that I probably don't need, but more specifically, I got some nuts and bolts that I definitely will need. With a fresh set of supplies and nuts and bolts, I can start drilling out the holes so that we can lock this piece of metal into place, as well as changing over that connector on the motor controller loom so that we're ready to actually plug into the motor.
we can begin to put this piece of metal in the frame so we can get the motor controller in and wired up. Oh gosh. Okay, so the main cables for the motor are just that tiny bit too short. That's really unfortunate. I've put in a lot of effort to get everything exactly where it is. I do still have the option of moving this motor controller so it's on top of the base rather than keeping the heat fins under the base. With that knowledge in mind, that's exactly what I do. I take it out from being mounted from below to being mounted on top, locking the controller in place with this new metal sheet. Now we're finally ready to put the batteries in and tackle another problem. So I've got a wonderful new problem. This is where I was welding over all that time, and the weld has built up so much that the battery can no longer fit in the battery slot. One option I have is to remove this little bar here. This holds the battery in this battery slot. And I think if I simply just move it forward a little bit, we can maneuver around this little issue here. Though it's not the ideal way to solve this problem, but it is starting to look like the only way I can solve this problem. As it's such a simple problem, wood seems to be a great way to solve it, though I do hope this isn't a permanent solution and just something temporary until I start working on more body stuff. With the batteries in, it's time to get them all wired up. Sorting out the old wiring loom and balance system, I do realize that I need a new main positive cable, so we make that up as well. With all the batteries being wired up, it's time to install that sketchy Chinese app onto my phone so I can take proper control of this motor controller via its Bluetooth adapter. Don't worry, this will change. Finishing up some tests and diagnosis and some back and forth with the manufacturer of this motor controller to ensure that everything is programmed and connected and working properly, we can finally start to think about taking it for a little bit of a test drive on the road at least 80% power. Now admittedly, the brakes are squeaky, not because they work, but because they're completely disengaged, don't work, and they're just sort of flopping there. So I just got to ignore that. Now, let's try slow, easy driving. Whoa, 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 whoa! It's very responsive. Very, very responsive. Let me see. I'm using about 200 watt, 300 watt, pushing me along like this. 10 amps. Let's just do a bit of a push. Whoa! Yep. I got a whole lot of power there, that's for sure. Oh my gosh. Okay, this thing sounds like it really wants to take off. So, right before this camera's battery goes flat, I'm gonna try a grass pull. I'll put it on the grass and see what happens if I fully accelerate. Oh shit! Okay, maybe not the best idea. Oh no. probably not the best idea. So this new motor controller has a ton of power in it, and it is willing to rip up any bit of grass that stands in its way, which I so happen to find out. Well, I guess I'm just glad it works. But now we know how this goes on grass. Bit rough. Let's just quickly try it out on the concrete. Whoa, whoa. All right. Yeah, she's pretty good, eh? Yeah, great. Great new controller. Quite a... I really got to hold on. My finger got caught in the disc brake. Okay, Okay, I need a safer way to stop. Mail time. I haven't been ordering a lot lately, because I'm broke. It finally caught up with me. A couple of smart plugs. So these are the Zigbee power monitoring smart plugs I have around the house. They are super useful. Connect them to Home Assistant. I can see how much power each device is using, and I can also remotely turn it off and on. Looking at the small one, I'm guessing this is my DJI Osmo Pocket 3 lens protectors, screen protector. Sorry, says it's a screen protector, and there are two in here, a screen protector and a lens protector. I wish I got these earlier because all the welding and grinding, I've actually been flicking little bits of metal up onto the lens and it's permanently damaged now. Turquoise? Oh, of course. You know, life is all about safety first. Oh, at least it is for some people. And who's safer than Hello Kitty riding a tricycle without a helmet? So, of course, I got these one-time use, shouldn't be using these more than once, disposable gloves, just in case you need to use some gloves for something. I now have 1,000 individually wrapped, disposable Hello Kitty themed wrapping gloves. Looks like I'm going into food preparation. This one is, I mean, not a bog standard one, but it's a USB-C charging cable. It's one of the ones with the little magnetic end so that you're not constantly plugging in and unplugging your charge cable and slowly wearing down and damaging your charge port. Here, I already know what it is because I specifically ordered just one of them. I may have ordered two. Two lights, which should hopefully be very bright. 4 meters should work on my local power, though this plug is not what we use here in New Zealand. Ours look a little bit more like the screen mask, but that's okay because I have this adapter. So let's plug it in and see how well it works. Oh, look at that. Oh, this is... Okay, with it static, it's fine, but I can see that there's no capacitors or anything in this. So it moving around like this is very uncomfortable for my eyes. And yeah, you can see how there's this rolling. Yeah, I'll do it like that. There you go. You really see right here. You see we've got this rolling black lines here. So that's the LEDs themselves. They're probably turning on and off 50 times a second because I live in a 50 hertz country. Maybe if I look at it with my phone, oh, my phone is really flashing here. It is not too interested in it. So if I go into slow motion, you can see it's turning off and on very, very rapidly. I'm guessing in here, all that's really happening, considering it says AC, DC, is there's no step down voltage or anything. It's just purely going in, using a couple transistors or MOSFETs or even maybe just a single bridge rectifier, and then boom, straight out to the LEDs. So I would consider this isn't even being powered correctly. And what? Oh, look at this. I don't unclip that. Okay. Let's go have a look and see what's coming out of these pins. I'm going to go without the ground cable at first, just because I don't want to accidentally have this grounding, which is earth to the same place, come back and blow it up, even though it shouldn't. Everything is isolated, but I don't want to take the risk right now. Turning the switch on in 3, 2, 1. Look! One thing I'm liking is that this readout is giving some correct information. It's running at 50 hertz. And what this is telling me is that it's not even a full bridge rectifier. Simply put, with AC power, we've got the 0 line, and because I live in New Zealand, we're running at 50 hertz as indicated by the oscilloscope successfully. That's a good sign that it's able to pick that up. AC power works by going up into a, we'll say, positive point. So there, it'll be positive 215 right now. That number changes depending on the power load and stuff on the grid. It'll variate. Usually all of our stuff and equipment is rated for 250 volts, I think, or 240 volts AC. But usually the voltage is a little lower, but it does fluctuate. Anyway, so it comes up like that, and then it comes back down to 0, and instead of stopping like it has there, it keeps going to a negative value of 215 as well. And then of course it comes back up, and that cycle continues indefinitely throughout the duration that the power is live. And so what's happened here is, in order to make a DC output here on these 2 pins, is they just got rid of the negative. Like they just got rid of half of it. You can flip that up so that you get a nice bouncy bit there, but that means that, well, this is happening 50 times a second. Half the time you're getting no power. Half the time these lights are off and not powered. If this sparks, I'm going to get a fright. Oh! Okay, there we go. So exactly what I didn't want happened there. And I've lost power to the garage, which is unfortunate because I've got a server out here running, doing a few tasks. I really should have a UPS unit out here. All right, that's the workspace back up and running again. All right, so it seems that I have completely fried this little unit, so it's a little unfortunate, but what we saw was exactly as I expected. There is no capacitors in here, there is no smoothing of the DC voltage coming out here, so you get that gross, jagged, up and down AC look that that gives a lot of people, I'm sure a lot of people get headaches and stuff from looking at lights that are just poorly built like that. So I now know that this is a pretty high voltage DC light that is more or less useless. Even the second one that I've got here that is still in the wrapper and probably perfectly fine, I can't really use it because it's just going to give me a headache. I've got this old mobility scooter. Now I can't remember if I actually uploaded the video of it. It may only be on TikTok. I'm not entirely sure what happened to that content. But what I did is I purchased a perfectly fine working mobility scooter and then pulled it apart to the point where it no longer works. With this sitting here doing absolutely nothing and in line to go to the scrap metal, let's pull this chair off and see if we can fit that on the go-kart. Hopefully then I'll have a more comfortable ride. Alright, now I can't put it on with all this extra framing bit on it. So I'm going to take off the metal bits, which means we will lose these armrests, but honestly they seem kind of useless anyway.
Unscrewing, unscrewing, I am unscrewing things. Unscrew.
I think this is the way to go. Yes, you got to have your legs spread right open, but oh man. It's just, it's so much better than before. You have no idea how much this seat has changed this. This has changed things a lot. Whoops. Okay, ideally I won't be crashing like that in future, but it turns out this seat works wonderfully. Just got absolutely saturated. That was a massive puddle.